All right, guys. Good afternoon. I will not be starting right now, but I would like to introduce Alisa. Alisa has been our longest-serving tutor for math for New Horizon for last 10 years almost, I would say. Yeah, time flies. And this is the first time she's actually teaching ACT group class on a specific topic. Okay, so help me welcome. She's um, expecting mother as well. So wish her the best, but don't give her a lot of trouble. Okay. So I'll see you guys in an hour, and then you know the protocol. Okay. So have your calculators. Let's get going.
Perfect.
And I've started recording, and it's all good to go.
Okay.
And you may want to keep an eye on this one. Sometimes students do join late. Oh, see, right there you go. So I want to just.
Yeah, just leave it like
Yeah.
that. That'll be good.
Okay.
Perfect. Thank you.
Yep. Actually, I'm gonna keep this door open, so otherwise it gets really hot in here.
Okay.
I'm gonna close that now.
Okay, sounds good. Okay, as Manoj said, my name's Alyssa. I don't know if you guys know the topics that you're going to be going over beforehand. No? Okay, well, this will be fun then. We're doing like probability and statistics stuff. And so the first thing that we're going to talk about is your measures of center as well as range. So measures of center, we have 3 of them. If you guys can't read anything that I write on the board, just let me know. Also, I'm apologizing in advance because I am an awful speller. So if I spell something wrong, just let me know. So in terms of like probability and statistics, we have 3 measures of center. And the 3 that we have are mean, median, and mode. So the first one, mean. This is the one that we probably use, people are most familiar with, and that's because mean is like how you would think of like your arithmetic. Average. Do you guys know like the formula for average? Yes, perfect. So, I'm just going to use u is equal to, they'll put like x1 plus x2 plus x to the n, all divided by n. Where these are the numbers you're taking the average of. Values averaging. And then n is the number of values. The next measure of center that we have is the median. So for the median, I like to think of the median, it's, all of these start with M, so there's like not a good way to like distinguish them like in terms of the first letter. So median literally means the middle value. I also think of median like the median in like a road. It's in the middle of the lanes going this way and the lanes going that way. And so that's how I think of it here. So to find the median, the steps to find it, first is you have to put your values smallest to largest. So put numbers smallest to largest. They will try to trip you up, and they're just going to put like all your data and like it's not going to be in numerical order, and they're just kind of testing to make sure you know you have to put it in numerical order to do it this way. The next thing is you have to look at how many numbers you have. So if we have an odd number of values, so odd number, you literally take the middle number. So then you find middle number. 7 values, the middle number would be the fourth one, and that would be your median. If it's even, we don't technically have like a middle number, so what we end up doing is we take like the two middle numbers and you find the average of the two middle numbers. Any questions so far? Okay, so then the last one that we have, so we have mean, median, and the last one is mode. And this one you can think of as most often. And the way that I remember this is, it's kind of dumb, but they both start with MO. And so that's how I remember it. So for most often, we're literally looking at how many times a number shows up in the data. In our mode, we have ways to describe it. They are, we can have unimodal, bimodal, bimodal, multimodal, and no mode. Unimodal just means there's one number that shows up the most amount of times. Most times. Bimodal, there's two numbers that show up the same amount of times and it's the most. So, two numbers most times. Multimodal, you have 3+ numbers most times. No mode just means that they all show up the same amount of times. All show up equal amount. And before we get to an example, there's one more thing that we want to talk about. It's not dealing with your measures of center, but it still deals with when you're looking at data sets, and that's your range. So your range, this just basically tells you like how far is your data dispersed. And so your range is the difference between the largest value and smallest value. Okay, any questions so far? Okay, so we're going to do an example. I am going to put some numbers up here, and I want you guys to find the mean, median, mode, and the range. So is everyone good if I erase the board? Yeah? Okay. Perfect. So find mean, median, mode, and range. And let me get these numbers. Okay. 84, 80, 82, 77, 78, 80, 79, and 42. Okay, I'm gonna give you guys like, I don't know, 2-3 minutes to see if you guys can find those four pieces of information. And then if you guys have found those, I want you to like plot them on a number line as well as your data points. So I'm gonna start doing that with our data points, just so we can see. Doesn't have to be like a super accurate, just kind of. Okay, so what did you guys get for the, let's do the median first.
Is it a decimal?
Yeah.
Okay, then 79.5.
Good, good. So for the median, this one, what does it mean? Like, if you had to describe the median to somebody.
Middle value.
Good, the middle value. How many sets of, or how many data points do we have?
8.
8. Good. So we have an even number. So right off the bat, we know we have to average the two middle numbers. Which implies we gotta average two middle. So what's the first thing we need to do?
Put 'em in order.
Good, we gotta put them in order. So we have 42, 77, 78, 79, 80, 80, 82, 84. Is that what you guys have? Yeah. Good. No, because we have a small amount, sometimes, I'm gonna be honest with you guys, I'm really lazy and I don't wanna count them. So I'll just start like, take one off here, take one off. And then I see that these are my two middle numbers. In your head, if you know it's 79 and 80, the middle would be 79.5. If I had to average it, how would I average it?
Just add them both from.
Good. 79 plus 80 divided by 2, and that would give me 79.5. Perfect. So I'm just gonna put up here, the median equals 79.5. What about the mode?
80.
Good. 80. Is this unimodal, bimodal, multimodal? Unimodal. Good. Why is it unimodal?
Because there's only
Yeah, good. So 80, all of them show up once besides 80. Let's say, I don't know, they just tacked on another like 42. Then it would be bimodal because 80 shows up twice and 42 shows up twice. So that's how I would know. So really quick, I'm gonna write down, is this, okay, yeah, that is visible to me. Mode equals most often. This one is 80. Okay, so the mode equals 80. What about the mean? What did we get for the mean?
75.25.
Good, good. So the mean is like our average. Or I'm just gonna say, the reason I'm adding in arithmetic, it seems kind of, I don't know, it's like, why are you adding it in? Why don't we just say average? Part of the reason is because when you get into like, if you guys do take higher levels of like, actually take a stats class, they'll call all of these like your averages. And that's why I'm adding like the arithmetic average. So for this one, we would have to add them all up. I'm just gonna go off of that part. 82, 77, 78, 80, 79, 42. And what number am I dividing by?
8.
Good. Why?
Because there's 8 numbers.
Good. There's 8 numbers. I don't know what people normally use for this. What's it called X? In stats, they'll like start to use like Greek letters, and so like you'll see a weird like looks like a funky U. It's pronounced like mu. So sometimes you use X and sometimes you use the Greek letter. We'll just go with normal. And then you said we got 75.25. Perfect. So the median. No. The mean. 75.25. And I didn't really ask for it, but what is the range for this?
42.
42. And how do we find the range?
The largest one is the smallest.
Good. So the range is the difference between our values. Our largest one was 84. Our smallest one was 42. That gives us, ironically, 42. Good. Okay, so the reason that I had us like graph these numbers is we want to see how do our three like averages or measures of center compare to the data. So if I do the median, well, I kind of graphed these all in pink. So we'll do the median in black, I guess. It's really hard to see my data, but I have them like all bunched up like right here. So this is 80, so our median is about here, 79.5. Our mode is at 80. And then our mean is 75.25. So what would you say about these three measures of center? Are they similar? Are they different? Like, what would you say?
So,
They're pretty similar. Our mean is pretty low. Why?
because of 42 for the town.
Good. This 42, like, all of our data is, like, right here. This 42 is, like, all the way down there, and because it gets actually calculated into your mean, it has a really big impact on it. Whereas when we do our, like, median and our mode, it doesn't have an impact because your median, well, you're just crossing out the smallest values. So if you just have, like, one outlier, or if we had, like, one that was crazy off here, it doesn't have an impact. You're crossing it off. And then for your mode, well, it's just one number, so it's showing up one time. It's not showing up multiple times. So again, it's not having an impact. So when you do your mean, having these outlier values will have an impact on your answer. Any questions so far? Okay. So we are going to focus a little bit on the mean or the arithmetic average, because on the ACT, I believe there are a lot of problems that have to deal with finding the average. So, we're gonna do one here. Okay. Sweet. Okay, here is our problem. We have Bob downloaded 5 new songs. From Apple Music. He knows that on average, the songs cost $1.23 each. If 4 of the songs cost $1.29 each, how much did the 5th song cost? I'll give you guys like a couple minutes to work on this one here. Before we even solve this, do we expect this fifth song to be higher or lower than the average? Good, why?
Because the songs are $1.29 each, so the first four, so it'd have to bring it down to
Perfect.
the average.
Yeah, so if our average is 123, and we know the 4 songs cost 129 each, there's no way that our average can be $1.23 if the 5th song cost more than the average. So let's use our average formula to solve this. We know it's x equals x1, x2, xn all over n. So where does the $1.23 go in this formula?
That's what it equals.
Good, so that's like what my average is. So I know that I should have $1.23 equals, what else do I know?
That you should multiply the 129 times 4.
Good, so technically I have 129 4 times. I could write it all out.
It's $5.16.
Good, but I know that it's just, I have it 4 times. I know that I want to find the 5th song, so that's the value that I'm going to be solving for. And what am I dividing by? 5. Good. So to solve for this, I'd multiply by 5 on both sides. I should probably do it like that, that's messy. This gives me, I don't know what that is, 615 equals 129 times 4. What did you say 129 times 4?
5.16.
5.16 plus x. To solve for x, I subtract the 516 over. And this gives me 99 cents. Which is what we thought. It should be less than what our average was. Any questions on this one? Okay. We're gonna do another average problem. Alright. Okay, so we have the, I don't know, teacher asked 15 students in class how many TVs in their house. Here are the results. So the number of TVs and then number of homes. Two, three. Okay. 1, 2, 3, 4, 5. So the question is, what is the arithmetic mean? Also, I'll put up the answers, I guess, because this is an ACT. So your options, A, B, 4/3, 6/3, 8/3, 10/3. Give you guys like 2 minutes here. Before even solving, what numbers or like which values do I know that I could probably eliminate right away? Yeah.
Like 2/3 and 4/3, cause they're like too long.
Good. So this is like not even one. And like we had 3 houses that were like 1 and under. So right off the bat, I know that this can't be 1. And same reason. This is just barely over 1. And like we said, there's 3 houses here compared to 12. Once we get to these, you don't want to eliminate too many, but like just to kind of give you a better idea. So we know it should be one of those 3. To do this, I know that my average is going to equal. Now, because we have it written in this sort of a chart, you want to think of it as this number shows up 1 time, this number shows up 2 times, and so really I'm going to be multiplying these numbers together and then adding them in my like arithmetic mean. So I have 0 times 1 plus 1 times 2 plus 2 times 3 times 4 times 4 plus 4 times 5. What number am I dividing by? 15. Good. Something to just kind of keep in mind. Yes, I know that 0 times 1 is going to go away. And so it's going to look like if you wrote them all out, it looks like we only have 14 values, but that 0 is significant. So you do have to include it in your answer, or in your like solving process. So we get 0 plus 2 plus 6 plus 12 plus 20 over 15. That is 40, right? 40? I don't know. Okay. 40 over 15. And what does that reduce down to?
8 over 3.
8 over 3. Good. Good. And so that's about 2.67. You repeat the 6. Good. And so that means that our answer is D. Any questions on how we did this one? Okay, so kind of using the same like problem, we're kind of going off of it. I'm just gonna, I don't think I'm gonna write it all out. So let's say that now, kind of using the same chart. I'm just gonna erase this. I guess I'll erase the problem too. There's actually 16 people in the class. So, 16 people in the class. But one was gone when the data was taken. When the student returns, oh gosh. The teacher asks him the number of TVs in his home. The new median, well, we're gonna do it this way. The new arithmetic mean is, and here's your choices. 2, 2.5, 3, 3.5, or cannot be determined. What do you guys think?
Can't really do anything if we don't know how many TVs we're missing.
Good, good. So we can't figure it out. The way that we know is we know that your average is equal to your data points divided by the number that we're dividing by. So if we fill in the data that we know that we have, well, we don't know what the average is, that's what we want to find. We know most of the data points, I don't know, the one, yeah, I don't really want to, 0 times 1 plus whatever, 1 times 2, 4 times 5. Plus, we're going to call the new data point y, and we would divide by 16. I have to add 1 because I have another person. And so from here, I only have one formula, but I have 2 things that I don't know. Have you guys done like system of equations, stuff like that? So I don't know if you guys talked about it, but however many like pieces of data you don't know is the number of like equations you have to have. So in order for us to solve this, we would have to have another equation. Since we don't, we can't determine. What about if I asked you what the median is?
That also probably cannot be determined because it could be the median.
So for the median, if I did this as the median, we'd have to put all of our like data sets in order. And we know that we'd have to like find the average between the 2 middle ones. Well, I have no clue what this person's data set is. So like I don't know if it's like to the left of the middle, to the right of the middle, or if it's one of the values that I actually need to calculate the middle. So in either case, it would be E. What do you think for the mode?
We still have no idea.
Also the same, right? I mean, I guess somebody could say, well, it's going to be 4 because that's the biggest number. And it's like, yes, but what if he had three TVs in his home? Then, like, these would both show up 5 times, which means that they're both the mode. So if you have problems like this, you have to, it's okay to get an answer that says it cannot be determined. Yes.
What if you like made another equation, but you put y in terms of x? Then could you solve the equation? Or?
If you had enough data to create an equation where you had y in terms of x, then you could.
Well, I mean, what if you put that equation with y in terms of x? Could we solve that or no?
Like, what do you mean, putting it in y in terms of x?
Like we solve for y, basically.
So
and we make its own equation.
you could, but then you're getting into like a cyclic pattern because now we don't know x, and you need to know x to solve for y. So you'd have to have like a completely separate, like not this average, equation. But that's a good question. That's a good question. Any questions on this stuff? Okay, so the next thing that we gotta talk about is probability. Have you guys talked about probability before? Yes. No. So probability, it really just has like one equation, which I kind of seems weird because like it's an entire topic on its own. I guess what is probability?
Isn't it like the chances that something's gonna happen?
Yeah.
Or like a number would show up?
The, I don't know, likelihood and event. We're gonna call the event E will happen. This formula that we use to find the probability. So we would write it as the probability of event E is equal to, and it's kind of, I don't know, people use different formulas. I'm just gonna put F over S. Where F is the number of times or ways event E can happen. And S is the, well, we call this a sample space. And your sample space is like all of the different ways whatever you're dealing can happen. That sounds very vague, but what I mean is like if you're rolling a dice, like there's 6 sides to a dice, so your sample space would be 6. If we were doing something with the number of days of the week, well, there's 7 days of the week, it would be 7. So I would say this is the total number of outcomes. That's probably a better way to say this. Now you can get into things like experimental probability and like theoretical probability. They're the same thing. You're calculating it the same way. It's just an example of like experimental probability is like I give you each a penny and you guys flip it 10 times. Well, how many times did you get heads? You would tell me like, I don't know, I got it 3 out of 10. I got it 4 out of 10. That would be experimental because you guys actually like counted what you did. Theoretical is more like we know on average like it should be like 1 in 2 chance. Like there's only one way to get heads, and your sample space is either heads or tails, so it's 2. In terms of like taking the ACT, I don't think that they're gonna really get into the difference between them. Your probability, should your probability number fall between? What do you think?
Like 1 in 100 or something? The percentage?
So you actually, you're on the right track. Yes.
0 of 1, because we're writing it as a fraction.
Good. So as like a decimal, it would be between like 0 and 1, but as a percentage, that would be between 0 and 100. So numerically, it's always between 0 and 1. The closer it is to 0, that means it's not going to happen. The closer it is to 1, there's a higher chance of happening. So if they say like there's a 0.1% chance of rain tomorrow, is it likely to rain or not likely? Not likely. Good. The way that we write probabilities, so we will write these, so ways to write. You can do it as a fraction, as a decimal, or as a percentage. Those are the ways that we would usually write probability. So, you guys good for a race? Yeah, okay. Here is an example. So let's say Martha has a box of 17 different we'll just say CDs because it's shorter. She has 5 rock, 3 blues, 6 pop, and 3 R&B. What is the likelihood of the following? So the first is if she pulls rock, blues, pop, and then R&B. I'd probably just, instead of likelihood, I'm gonna say probability. That's okay, just because of time's sake, we're gonna do this one together. So, probability of rock. We know that probability is just gonna be a fraction. What are the total number of like possibilities that I have?
17.
17, good. So that's gonna be my denominator. How many, this is gonna sound a little weird, but how many ways can she choose rock? Good. There's like 5 different CDs, so she has 5 ways of pulling out a rock CD. So the probability of rock is 5/17. Using that same logic, what's the probability of pulling out a blue CD?
3/17.
Good. 3/17. And pop?
6/17.
6/17. And then R and B? 3/17. These are the only types of CDs that she has. So if I would add them all up, 5/17, 3/17, I should get 1. There's no other possibility that could happen. Which we see if I add them all up, we get 8, 14, 15, 16, 17, which equals 1. I like to do that just to make sure that I didn't miss any of them. If it equals 1, that means I have all of the different like possibilities counted for. Any questions? No. Okay. I don't know if I have. What time is it? Okay. It's like a minute before you guys take a break. So does he just turn these off then, or?
Yeah, I think he turns the recording off. I don't know what happens with these.
Well, it's just the video.